Chapter 9, Lesson 9, Cubic and Exponential Functions. Okay, let's first talk about a cubic function, a function that can be described by the equation y equals ax cubed plus bx plus cx plus d. So similar to our quadratic equations, the a cannot equal 0. So if this a is 0, what that does is it takes out this cubic part of it. So the a cannot equal 0. The b could equal 0, the c could equal 0, the d could equal 0. Part of it could, some of it could, all of it could. You might just see y equals x cubed. Or you might see y equals x cubed minus 2x squared. Or you might see y equals 3x cubed minus 1. All of those are cubic functions. Okay, let's look what happens when we graph a cubic function. So let's plug in some values for y equals 2x cubed. So if x is 2, then x cubed is negative 8 times 2 is negative 16. If x is negative 1 cubed is negative 1 times 2 is negative 2. If x is 0, 0 times 2 is 0. If x is 1 cubed is 1 times 2 is 2. If x is 2, x cubed is 8 times 2 is 16. If I plot those, now I can either choose to plot some points like in between 1 and 2, negative 1 and negative 2, or I can choose to plot these and maybe count by 2's on my graph. So I'm going to count by 2's. Okay, so for my first point, I'm going to go negative 2, negative 16, but I'm only going to go down to 1, 2, 3, 4, 5, 6, 7, down to negative 8 because I'm counting by 2, so negative 16, negative 2, negative 16. Negative 1, negative 2, 0, 0, 1, 2, and 2, 16. Now if you notice, this almost appears to look like a line, but in a cubic function, the shape is what we call the cubic curve. And so it goes up, curves over, and then up this way. So it's going to have a curve on it. It's not just going to be a straight line that connects the dots. And that's what every cubic function will look like. Okay? An exponential function is a function that can be described by an equation y equals a to the x power plus c. Now this time a little bit different. Our a here cannot be 0 because then we have 0 to different powers, which is nothing. And it cannot be 1 because what's going to happen is if I do 1 to different powers, if x is 4 or 5 or 6, it still stays a 1, and it's just going to be the same point. All right, so if I was going to graph 2 to the x power plus 1, so if x is negative 2, 2 to the negative second power is 1/4, plus 1 is 1 1/4. If x is negative 1, 2 to the negative first power is 1/2, plus 1 is 1 1/2. If x is 0, 2 to the 0 power, don't forget, is 1, plus 1 is 2. If x is 1, 2 to the first power is 2, plus 1 is 3. If x is 2, 2 to the second power is 4, 4 plus 1 is 5. Now I'm going to graph these points. So I'm going to go negative 2, and then I'm going to go up to 1 1/4. Negative 1, I'm going to go up to 1 1/2. 0, 2, 1, 3, and 2, 5. Now if we notice, this one makes what we call an exponential curve. And there's my exponential curve. Now, what I want you to be able to do is to recognize from a graph if this is a linear function, a quadratic function, a cubic function, or exponential function. So when we talk about our general characteristics, a linear function is obviously going to be a line on our graph. Quadratic is going to be a U shape. Remember, of course, it can be upside down, it can be to the sides, whatever. Cubic is going to have this general shape, and exponential is going to be an exponential curve. And then the formulas are, for a linear equation, y equals mx plus b. For a quadratic is y equals ax squared plus bx plus c. For a cubic, y equals ax cubed plus bx squared plus cx, plus d. And for an exponential, y equals a to the x plus c.